Could you read the question?
It says sketch stacks of object for an object free falling. A, the slope
Okay.
of the position versus time graph.
Oh, beautiful. Do you want just falling, or do you want thrown up? What do you want? Because free fall is thrown up, or it could be thrown down, or it could be dropped from rest. What do you want? The simplest is dropped from rest.
Alright, let's do drop from rest.
Okay, so like if an object's dropped from rest, the motion map looks like this, right? I'm just starting with a motion map to wrap my brain around the situation, okay?
I already know my friend.
This would be an object in free fall that's dropped from rest with, that means the beginning velocity was like 0. Even when the velocity was 0, there was acceleration. You get what I mean?
Yes.
Oh, wait, I just messed up because the acceleration never changes.
Constant.
Yeah, that's the acceleration. Objects in free fall have an acceleration of 9.8 meter per second squared down, which is the same as 9.8 meter per second, which is about the same as 10 meter per second.
Okay.
And yeah, always, we're ignoring air. I'll write that if we ignore air. So really, these are constant acceleration problems where you know the acceleration. So they're easy.
Okay.
All right.
How about C?
Okay. So, well, I didn't do A yet. I just did a motion map. I usually do that just to understand the problem. So we want a stack of graphs then, right?
Yeah.
Do you want down to be positive or up?
Down.
Okay, cool. So that means my accelerations are positive and my velocities are positive. I like your choice. I like your thinking. You make down positive because you noticed all these vectors are pointed down.
Yes.
All right. So position. Why is it doing that? Hold on. My hand made a mark on it. Okay, so there we go. So I'll draw position. I'll use Y because you're talking about something in free fall. And then I'll draw the graphs real quick. So Y, velocity in the Y direction versus time, acceleration in the Y direction versus time, and the units for acceleration, as you know, are meters per second squared, times in seconds. So I'm just putting my units on my graphs. And these graphs are really just supposed to be sketches. You don't have to like spend forever on them. So can you tell me what the acceleration graph is going to look like?
It's going to be a constant speed line because that's
Not constant speed, constant what?
Acceleration.
Beautiful.
Because it's not changing.
Yeah, and we know this number is 9.8, which we're going to round to 10. Yeah, good. And then, can you tell me what the velocity graph is going to look like?
It's going to look like
Oh, that would be, what you drew was if you threw the object up first.
also.
But this object was released from rest, so the beginning velocity is 0. So what will it look like?
So it goes upwards.
Beautiful. Yeah, for sure, bro. And then what does the Y versus T, the position time graph, look like? Curve or line?
It's going to look like a curve.
Yeah, is the slope getting steeper or less steep?
It's less steep.
And what you just drew was an object slowing down and then speeding up with that curve. This is just an object that
From
speeds
rest.
up. Yeah. So you want, and notice all these velocities are positive. So I need positive slopes that get steeper. Something like that. And then I'll just connect it into a line, into a curve. Make sense? Something like that would be our curve. Does that help? So let's see if we answered all the questions yet. What's the slope of position time graph? Well, this slope is our velocity for our position time graph, right?
Yeah.
And so those slopes get steeper, meaning the object's speeding up, right? And those slopes are positive, meaning the velocity is positive. What's the next question? What's the meaning of the slope of the velocity time graph? Will you tell me? What's the slope of a velocity time graph?
Slope is the acceleration it has.
Good, yeah. And you can see that the acceleration,
It's increased.
well, careful, it's not changing because this slope is constant because you have a line. So that's tricky. So the acceleration's constant, it's not changing, and it looks like in this case the acceleration's positive, and you notice that matches our motion map. You good?
Yeah, you're good.
All right. And then you can also see from this lower graph that acceleration is constant as well because the acceleration doesn't change.
Yeah.
And then what's the next question? The areas, I bet. You also need to know about the areas.
What is the meaning of the area
Yeah.
enclosed by the acceleration graph?
Okay, let's look here. What do you think this area represents?
That I don't understand the
Okay.
area part.
Well, it's a rectangle, right?
Oh yeah.
And the units of the rectangle, I'm going to use the units to figure it out. Units are meters per second squared times seconds, right?
Yes.
What does that give you? Seconds over 1 times meters over seconds squared. What are you going to be left with? Meters per.
Sorry.
Good. And that tells me that this area must be a change. Those are the units that measure a change in
Acceleration.
close meters per second measures
velocity.
what? Beautiful, you got it. So if you ever forget, you can always use the units to figure out what that area means. And I'll use the same trick here on my velocity graph. Okay? So if I look at this area, I'm like, oh, that's a triangle. Base times height divided by 2. Well, the base is measured in seconds. The height is measured in meters per second. When I multiply those, what do I get?
Meters.
Good. That's a change in what?
And position.
Good. You got it. So you see, you can use the units to figure out what your areas of a graph mean. And we don't really deal with the area of a position graph. So we all good now.
All
Is
right.
that's all number 3?
Yeah.
We're good. And notice it says in the question, what is the meaning of the area enclosed? Because these graphs could be below the time axis. You always want to shade in between the time axis and the graph to find the area. It could make a triangle, it could make a rectangle, it could make a trapezoid, and then you'd have to add the triangle and the rectangle. A lot of people had trouble with that on the quiz because that was kind of cruel. I made it was a trapezoid and you guys hadn't seen that before. So, but it's possible, right? Okay, there we go. I'll post this. Thanks.